Alright, welcome back guys. So in this last video of 4.1, we're just going to do several examples, discuss different way of calculating probability of certain event occur. We're going to start with example 3. This one say that in a recent Harris Interactive survey of 10 adults, 1,010 adults in the United States, show that 202 of them smoked. Find the probability that a random selected adult in the United States is a smoker. And find the probability that a random selected adult in the United States is not a smoker. So we're going to find the probability of any random selected adult in the United States from a survey of 202 that shows smoke out of 1,010. So in this case, we are using the relative frequency approach because we are conducting a survey and use that result from the survey to estimate the probability, or say if we have 202 out of 1,010 that smoke, we can say that the approximate probability of any random selected adult on the street in the United States is smoker is around at 202 over 1010. So we can say that if we want to write this a little more formal, we can say let A be the event that a randomly selected selected adult in the United States is a smoker. And then we also need to find the probability of a random selected adult in the United States not a smoker. So we can say A bar be the event of a random selected adult is not a smoker. So if we define these events, we don't have to rewrite them over and over again. We can just go straight and say, okay, P of A in this case is the probability of a random selected adult in the United States is a smoker. So we're not going to have the exact probability. We're going to say the estimate probability is out of 1,010, around 202 them are smoked. So that's about 80% or 20%, I believe. Let's see, 202 divided by 1010. So that's 20%, 0.2, right? And then the probability of a random selected adult is not a smoker. So that's 10 minus 202, which is 808 over 1,010. So that's roughly, 80%. So this is just using the survey to estimate the probability of a random selected adult in the street or randomly on the street or anywhere you want to estimate. So this is not equal likely chance. This is not relative frequency. This is not classical approach. Sorry, this is relative frequency. Relative frequency approach. So using a trial and experiment to estimate the probability of another event to occur. Exercise 4 here. Oh no, 6 here. This is subjective. We're gonna skip 4 because that's something I do in a classroom, but now we're not doing this in a classroom, so I'm gonna skip example 4. Exercise 6 is subjective. It depends on your experiment. In my case here, I have gotten stuck in elevator before, so I'm gonna say the probability or the chance of me getting stuck in the next elevator ride will probably around 10%. So stuck is estimated around 10%, right? Whereas another student might say getting stuck on the next elevator ride would be maybe really small, like 0.001, right? Less than 1%. So that's using subjective. Exercise 5, when you roll a die, this is 6-sided die, right? What is the probability that the die will land on a 6? Well, land on a 6, land on a 6. There are 6-sided in a die, right? And then there's only one number that is 6, so there's 1/6 chance that the die will land on a 6, right? So this is using classical approach. Okay. I'm gonna skip exercise 7. 8 you can do on your own. This has to do with cards. Let's see, this last example, rare event rule for inferential statistics. This last example here, or this last thing we discussed in 4.1, kind of gave us an insight into how probability tied to the statistics. How do we use the probability of certain event to occur and make a decision in inferential statistics, which come up in the second in the last 3 chapter of this class. That's when we are making decision or conclusion or inference on the entire population from a sample. So the definition saying that for the rare event rule for inferential statistics, it said that if under given assumption, the probability of a particular observed event is extremely small, we conclude that the assumption is probably not correct. So we're saying that given assumption, the probability for that assumption or a particular event, observed event from that assumption has an extremely small chance of happening, then we say that the assumption probably not correct. So we reject something that, doesn't have a high chance of happening. And that's what the rare event rule for inferential statistics is saying, that we rather go with a decision that is more sound because it has more chance happening versus not high chance happening. But that's not a good assumption, because just because an event to have a small probability of happening, it doesn't mean that it won't happen. Like, lightning's, you get struck by lightning, yeah, the chance of a person get struck by lightning is extremely small, but you can't rule out all the cases, because it does happen, and people have been getting struck by lightning before, or people have won the lottery before, right? So those are the assumptions, those are the particular observed event under given assumptions. So that's what we use for inferential statistics when we make a decision in the last 3 chapters. So for this next example, kind of give us an idea where we're heading as well. So it says here, for instance, the Genetics and IVF Institute has developed a method of gender selection so that couples could increase the likelihood of having a baby girl. So if you want to give birth to a girl, you want to use this gender selection method, and they claim that it's increased the chance of giving birth to a girl. So it said, instead of testing this is true or false, or this is effective or not, it said that using some of the real result, let's look at a more obvious example, right? Suppose we are randomly we suppose that 100 couple use a procedure for trying to have a baby girl. The result consists of 98 girls and 2 boys. We have 2 possible explanations for this results. So the obvious example would be, suppose randomly select 100 couples from the group of people that undergoing the procedure, use the gender selection method, and the result from the 100 randomly selected couple from the people who use the gender selection method, and the result consists of 98 girls and 2 boys. We have 2 possible explanations for this result. One is by chance. We say that the gender selection method is not effective, so the result and the result of 98 girls and 2 boys occur by chance. Second explanation, we said that result is not by chance. That result appears to be that the result did not occur by chance, so it appears that the gender selection technique is effective. So which explanation that we are more likely to not accept but support? I wouldn't say correct one here. So one there's about 48 to 52% chance of giving birth to a boy, a girl versus boy. So if the probability of giving birth to a girl is so close to a boy, like pretty close to 50-50, so you would think out of 100 couples that deliver a baby or giving birth to a girl, you would think the number of boy and girls are pretty close to like 50-50, not 98 girls and 2 boys. As a matter of fact, in the chapter 5, we can actually look at the theoretical model of this and calculate the exact percentage of, or the exact probability of an event that consists of 100 births, and the outcome of getting 98 girls and 2 boys is extremely small. It's way less than 1%. So the explanation we're going to go with is the result did not occur by chance, right? If we select 100 couples and we see this here, right, it did not occur by chance because the chance happened so small, so small, like extremely small. We're not gonna go with the fact that it happened by chance, but we're gonna go with the fact that this gender selection technique is effective. Therefore, this 100 couples here deliver 98 girls and 2 boys. So we're gonna go with that explanation as opposed to the saying that it did occur by chance because it is so small, right? So that's what the rare event rule for inferential statistics is saying, that under given assumption, and if we observe an event, okay, and the probability of that event is extremely small, we conclude that assumption is not correct. So what we're going to write here, we're going to say that the result of getting 98 girls out of 100 births is extremely small, less than 1%. So we reject the first explanation and say that the gender selection method is effective. Alright, so I'm going to end on this note here. In the next couple of videos, we're going to discuss the remaining 2 lessons of chapter 4.